First, the process will be a simple tank that's filled with water and have two digital level sensors. One is for high level and other for low level. Also, we're going to control two valves, one for filling the tank and another for empty the tank. This sensor will be attached to the 0.1 and 0.0 PLC input, and the valves will be attached to Q 0.0 and 0.1 output. It's a very simple process, but will be useful to understand how the simulation made with Python connect with a Siemens PLC, with a real Siemens PLC. To beginning, we're going to create a virtual environment, and I'm using Windows System for Linux and Visual Studio Code. Then I'm going to first create a virtual environment, and that's it. Python module B environment. Okay. Okay. Yes, I want this virtual environment. And now I'm going to activate environment, activate, and now have the virtual environment activated. And now I'm going to install one library. For this, I'm going to use one library. It's Python snap7. This library is for make the connection between Python and Siemens PLC. Okay, install it. Okay, perfect. Now we can start coding. We're going to start by creating a model of the tank. Then we're going to create a file, tank.py, and I'm going to use some classes to make it like a model. I'm, this is a simulation, and the simulation it will be time dependent. Then I'm going to import for time. Okay, and I'm going to create a class, name it tank. Okay, to init, define init, and I'm going to define some parameters I'm going to use. It will be the time of the creation of this instance, and I'm going to define some tanks parameters. This will be the flow of the at the input valve. Put the 10.0 liters per second. So that flow a little less, like 8 second. Okay, and I'm going to define the tank capacity. capacity, it will be equal to 100. This will be on liters too. I'm going to find the maximum level of the tank. This is for my sensor for when the level of the tank, well, you will see in the function, but this for define the max level for the sensor, for the high level sensor. But this will be in percent value. The level for the low level sensor. The level of the tank. At the beginning will be 0. And I'm going to need the state of the input valve. This is going to be a Boolean value, false. And the status of my output valve, also false. Okay, now I'm going to define some function to return the high level sensor. Return if my level is great or equal that my max level, my self dot max level my low level function, self dot level less or equal self dot minimum level, and finally I'm going to define my process function, self. Okay, this function is which one will be called every time to process the function of the tank. Then I'm going to first I'm going to define this time, this current time, and now I need the step time equal to now less last time, and now last time self dot last time equal now. Okay, and now I'm going to increase or decrease the level tank. If my in valve is active, then my level will increase. It will be to my step time by my inflow. This is divided by self capacity because I want to have the level in a percent value from 0 to 1. Okay, this is for increase and this is for decrease. It's like very similar with less, with outflow, okay, and finally I will return the values of my level sensors. Level will be the function low level, and my high level will be my function high level. I'm going to change this to low to be equal. Okay, then when I call my function process, this increase or decrease the tank level in function of which valve is active, and then return the status of the low level and high level sensors. Okay, that's everything. Now we're going to create another file to define the connection between Python and PLC. Schematic.py. And this function here is where we're going to need the S7 library, and also we're going to create a class PLC and going to init. Okay, on this class I will create a client from the library the snap 7. Create a client, and here also going to connect with the PLC. Here's the address. The rack is 0 and the slot 1 for the Simatic S7-1200 PLCs. And now I'm going to create another function with the I'm going to create another function to write a single input to the PLC. Okay, I want to pass to this function my divide where I want to write, and the bit that I want to change. Okay, now I'm going to this library only works with bytes. Then I'm going to read 1 byte, and then I'm going to modify before send it back. And this function I'm going to use, this function is read area. Now in this area value has to be it's to describe to the library what kind of memory I'm going to read, and for that I use snap7 types areas, and here I have PE. This is the area for the inputs of the PLC. Okay, then I'm going to use the DB number, but now with inputs this have to be 0. The star byte, it will be the PLC byte, and the size, it will be 1. I want to read 1 byte. Okay, now I'm going to change the value of 1 bit of this byte, and for that I'm going to use other function that from snap7, that is snap7.util.setBall. My byte array will be the data. My byte index it's 0, and my ball index will be my bit, and the value. Okay, I have to pass the value from here. Okay. Okay. And also I will need to read the output of the PLC. Very similar. But there's no need new data because only going to read. I'm going to the same read the entire byte. For this one, it will be a little different because this is not a input area, this is a output area. Output area is PA. So here is wrong. Okay. And now I'm going to return, but I want to return only one bool value. If I check the function, I have to send it by the right, that it's data, comma, byte index, it will be 0, and my ball index, that it PLC, my bit. Okay, and with that function will return a single bit, a bool value. Okay, now I'm going to save this. And finally, I'm going to create a last one file. We're going to call it my.py. Okay, and at this field I will call my other classes. And I will use time to. Okay, then I will create a TAN instance and a PLC instance. Okay, this will be a simulation. Then I'm going to create a while, endless while. Okay, and then I will call my tank to know the state of the sensors. Okay, and now I'm going to send to my PLC the values of my process. For that, I'm going to write inputs to the PLC. Remember, I'm going to use my 0.0 and 0.1. Then I'm going to write here my byte 0 and my bit 0, and this value it will be the high level. Then I'm going to put my tank state and the value of high level, and the same for the low level. Put 0.1 state, low level. Okay, and next I want to write more I want to read the output of the PLC and pass to my process. Then I'm going to use directly the variables of my tank. My in-valve state, it will be equal to my read from my PLC. Then my in-valve, it's 0.0, then it will be 0, 0, and my output valve will be 0.1. And I want to sleep a little bit. I'm going to start with 1 second. It will be the cycle time. Every second it will be checking the process. Okay, now with the program complete, I'm going to save, and I'm going to use the TIA portal. Now we have a new empty project. Then I'm going to add a new PLC. The PLC that I have, it's a 1215 DC relay. This one. Okay, I have this one. We need we need to do a few configuration steps before make the program in the hardware config. Okay, here is the PLC. Then I want to configure the entered address. I'm going to use the 1.15. We're going to we have to configure some protection settings. We need to have full access protection, full access no protection, and permit access put and get. Okay, now I'm going to define here a few tags. This will be the high level and low level, and also my output, it will be in valve and out valve. But if I use this configuration, my input don't work because how this work? I need to change my uh, properties of my PLC. I'm going to change the address of my digital inputs and outputs too. I'm going to pass to 10, for example. I need to end when this dialog appear. I need to let like this, like do not change tags. I want that. Okay, and the same here. Do not change tag. Okay, and also I'm going to change just that for now. Okay, and now I'm going to make a very simple program. Okay, I'm going to use my sensors to fill my tank. To use this will be my low level sensor, because I want to start when the tank detect low level, and I want to stop when the sensor detect high level. High level, and I want to active the input valve in valve, and also want this stay active here, and also going to put some mark here. There is very simple program, and I'm going to download to use my physical connection. There is my physical connection, and now I'm going to load. I have access from other TIA portal offline. Okay, okay, continue without synchronization. Stop all modules, load. And start module, finish. Okay, let's check if we can go online. Okay, there is. Now it's not inactive because, well, it's nothing connected to the PLC. Then I'm going to activate the simulation, this simulation. Okay, let's hope everything works. I'm going to activate it. We're running my Python my program. Okay. Ooh, there was a problem. Okay. Line 19. Mean level. Slow level. Let's check. Other typo. This is from 10. It's like when I call new value, it's not a valid expression. Of course, because here I don't have to write a value of a volume value. I have to write the entire byte. Then I have to put data here. Save, and again. Other one. Here I don't send the data. I just make the the byte, but never send it. I forget to send it. This is I'm going to write the same area. The number is 0. Start is specified, and data is data. Okay, let's check. So value is not the Boolean expression. Mine, line 11. Say tank state. Okay, here I forgot to return the values. return values, and now let's check again. The event number. Okay, here is I don't put complete this. 0. Start is PLC byte and size is 1. There you are. There is running. And let's check the mine. Okay, there is. And end. This end because when I start the simulation, we start at a zero value. If we check this, the beginning when create the tank, it's the level is 0. Then for that, my my low level is activated. Then my low level is activated, my high level is not activated, and then my in valve start and continue running until I have high level, because this open and stop. Now I can open the output valve and we'll check how this will be activated. High level deactivate, and then low level will deactivate. When low level activate, this start to run, and this will be more slow because I have activated my output valve. But if I deactivate, it will be more fast, but it will be faster because there is no water out of the tank, only filling the tank. Okay, and then the valve stop or the valve close, and there is the simulation. There is my tank simulation, there is my tank model, my connection to the PLC, and my mine process configuration. Okay.